Friends, the topic of my lecture is today the basic concepts of antenna, the different types of antenna used, the radiation mechanism, and its fundamental parameters of the antenna. So this is being covered under the atmospheric and the space physics, and you can see all the thumbnails on the pictures related. This is an important topics for the GSIG combined examination, barc, oces, and the ISRO scientist. Going into the detail, I will show you some syllabus. What are these? So in this lecture, we'll be covering the concepts of antenna and the basic consideration and the types. So what is antenna and how it is used? It is very crucial for effective communication system. It is basically a device for converting electrical energy and the radio wave. So basically it is a transducer which can transmit and receive the electromagnetic signal. So the common types of antenna includes the dipole antenna, monopole antenna, parabolic antenna. Everyone has its unique characteristics. So as I have already told, the antenna is basically an electrical device which can convert electric power into the radio wave or the vice versa. So it is working as an sensor, as an electromagnetic radiator, as a transducer, and an impedance matching device. So for radar application, an antenna can concentrate energy into a narrow beam. And most popularly used antennas are, you can see, parabolic antennas, planar faced, and electronically steered phased array. Talking about the reflector parabolic antennas, there's the main characteristics is that they are very high gain antennas which used in the radio astronomy and the microwave communication and the satellite tracking. There are also lens antennas are there, which is used for the high frequency application. They are convex, concave, convex plane lenses. And there is also microstrip antennas, which are rectangular or circular shape antenna. They are also used in aircraft, spacecraft, satellite, missiles, cars. So talking about the fundamental parameters of the antenna, their radiation power density, gain, bandwidth, polarization, these are there. So one of the important factors is the gain, that is the ratio of the radiation intensity with the total minus input power. So, and there is also polarization, which is basically the orientation of the electric vector of the antenna in space and the function of time. And it is in the range of frequencies antenna for which it will have an optimal performance, that is called that range of frequencies called the bandwidth of the antenna. So when we talk about the antenna, there is also a radiation mechanism of the antenna. So basically when there is an acceleration or the deceleration of the electric charges, the radiation will be produced due to the motion of the charges. So antennas can radiate or couple and concentrate the electromagnetic energy in the in the desired or assigned direction. So when we choose antenna, there are many electrical, mechanical, and the structural aspects which are to be taken into account. High gain, directivity are the basic requirements for the transmitting antenna, and it can have a size from very smaller size strip antenna to the very big antennas, thousands of these antennas. So as we all are conversing about that, there is a rate of change of current which can produce acceleration of the charge q, and corresponding to that there is also time average pointing vector of the equation, that is called w average, time average, that is half into real part of e cross h. So this is the pointing vector that in one of my lecture I have discussed in detail about the pointing vector. You can follow this lecture of mine. So next there is another concept called directivity of the antenna. So it is the ratio of the maximum radiation intensity, that is U max, of the target or subject antenna to the radiation intensity of the reference antenna, which is radiating the same power. So It is the this Umax is the radiation density of the subject antenna, U0 is the radiation intensity of the isotropic antenna. So, and we represent it in the decibel scale, that is 10 log d dimensionless in the dec. So there are different kinds of antennas to the satellite communication used for broadcasting, Wi-Fi, and also the cellular network. And its understanding can help us in designing effective communication for, I mean, that is designed for specific needs also. So nowadays there will be rapid growing for I mean application of the antennas. The size of the antennas is getting updated, smaller and smaller, with greater features. It covers a wide range of application. So it's a very important topic. This is my channel for physics and geophysics learning. You can like, share, and follow and comment, and turn on the bell notification icon to have more updates. If you have any question in that lecture, please feel free me to message or mail me. I'll be always ready to help you. Thank you very much.